Hello and welcome to this video. In this video, we're going to talk about cell references. Cell references in Excel identify the locations of a data in a worksheet like A1 or B2. Instead of hard coding values in the formulas, you can use these references to make your formula dynamic and responsive to data changes. By using different types of references, like relative reference, absolute reference, and mixed reference, you can control how formulas behave when copied across cells. Relative references change based on the position of the formula. Absolute references stay fixed, and mixed references offer a combination of both. This power is what makes Excel such a powerful tool for data analysis, budgeting, and reporting. The agenda for today's topic is shown on the screen. We will start with the definition of a cell, find out the number of rows and columns supported by Excel, learn basic data types, learn types of cell references, and finally, understand cell references with examples. Let's now move to the definition. According to the Microsoft official documentation, a cell is defined as an intersection of row and a column in a worksheet where you can enter and store data. For example, if this is a cell containing text, according to the definition, a cell is an intersection of row and a column. This is our cell. And a cell has an address. For example, the cell containing text here has an address K13, where K is a column identifier and 13 is the row number. Now let's move on to the next topic. Since Excel 2007 onwards, Excel supports 10,48,576 number of rows and 16,384 number of columns. Let's now verify these numbers. Select anywhere in the sheet, hold the control key down and press right arrow. You are taken to the last cell in the sheet, which is XFD. In any of this cell, just type equal to column and then select any cell in this column. Let me select XFD3, close the bracket and press enter. I can see the column number of the last column is 16,384, which implies the number of columns supported by Excel is 16,384. Now let us validate the number of rows supported by Excel. Again, select any cell in the sheet, hold the control key down and press down arrow. You are now taken to the last row in the Excel sheet and the row number is 10,48,576. We have verified the number of rows and columns. Let's now move on to the next topic, which is the basic data types. Excel support wide variety of data types. I will listed some basic data types here, like number, which is an integer number. It also supports decimal numbers like 45.6. There is a text support. There is a Boolean support like true and false. The support for date types, time, error values, and also if a cell contains nothing or if cell is empty, it is a blank data type. Let's now move on to the cell reference types. Excel supports 3 types of cell references. As you can see here, it supports relative reference, absolute reference, and a mixed reference. In a relative reference, both the column and the row are variables. In an absolute reference, both the column and row are fixed. In a mixed reference, either a column is variable or a row is variable. A dollar sign is used to indicate that a column or a row is fixed. You can see whichever has a dollar prefix becomes a fixed entity. For example, in a mixed reference, if the column has a dollar sign, column becomes fixed and a row is a variable. And if a row has a dollar prefix, then the column becomes a variable and the row is a fixed entity. I will demonstrate each of these using examples. In this example, we will understand types of cell references. As you can see on my sheet, I have a source table here with 4 columns and 4 rows, and with numbers 20, 25 to 28, both across rows and columns. Now let's start with relative cell reference. Click G4. Now double click and press enter. Select cell A4 and then press enter. Now this becomes relative reference because I don't have a dollar prefix for either column or a row. That means when I drag this cell across the columns, the second column value should come from the second column value of the source. The third column value in the destination should come from the third column value. And finally, the last column value should come from the last column value from the source. Now let's just drag this. And as you can see, the results are as we expect. H4 is reflecting B4, I4 is reflecting C4, and J4 is reflecting T4. So that's a classic example of relative cell reference. The same thing should apply for the rows as well. Let me drag it down vertically to other rows as well. Now you can see the value from A5 is copied over to G5. The value from A6 is copied over to G6 and so on. So this demonstrates the relative reference across both columns as well as rows. Now let's try out an example for an absolute cell reference. So come to G10, press equal to, and then select the cell A4. Now this is a relative reference. So to convert this to an absolute reference, press the key F4 on the keyboard. Now this is converted to an absolute reference. That means whether I drag this across multiple columns or multiple rows, each of these cells should have the same value, and that value should come from A4, which is 2025. So let's press enter over here. Now drag the cell across the columns and also drag the cell across rows. And as we expect, the values in these cells are all referring to the same value, which is A4. That's because each of these cell reference is an absolute cell reference. Now, for whatever reason, I change this to, let's say, number 1. You can see each of these cells refer to the same cell value. Let's move on to understand types of mixed cell references. Now, come to cell L4 and then type equal to, and then select the cell A4. Now, this is a relative reference. Now, let us convert this to a mixed cell reference and fix the column. To do that, press F4, press F4 once again, and press F4 once again. What this means is, when I drag this cell across the column, we are fixing the column here. That is, we are fixing the column A. The source value from A4 is copied across all other columns in the destination. That is the meaning of fixing the column. Once again, let me repeat. $A4 means we are fixing the source column to A4. That means when I drag this cell across other columns, the same value is reflected across all the cells. So let us try it out. As you can see, each of these values are all pointing to A4. Now, since we are only fixing the column and not fixing the row is a variable. That means when I drag this vertically down, the value of this destination cell should come from its corresponding source cell from the first column, which is A5. The value for L6 should come from A6 and so on. So let us drag this vertically down and observe the value. As expected, L5 is copied from A5, L6 from A6, L7 from A7. That demonstrate mixed cell reference where we are fixing the column. Let us go to the mixed cell reference and fix the row. Select this cell L10, type equal to, and then select our source cell A4. Convert this to mixed cell reference. Press F4. Once again press F4. Now we have fixed the row, but column is a variable. So what this implies is the inverse of the previous mixed cell example. So here we are fixing the row. That means if I drag this cell vertically downwards, we do not get values from the corresponding cells below this source cell. Instead, the value of the row will always come from this particular cell. That means we are fixing the row here. Even though you drag the cell vertically downwards, the cell value from A4 doesn't change, it remains the same. Now let me drag this vertically. As you can see, this is referring to A4. The cell value L12 is referring to A4 and L13 is also referring to A4. However, since we are only fixing the row and not the column, as I drag this cell across the columns next to the source cell is copied over. So the column is variable. That means the column is following the relative reference, whereas we have fixed the row. So let's try it out. As you drag across other columns, the source column is copied over to the corresponding destination column. In this case, M10 is copied from B4, N10 is copied from C4, and so on. This completes the demonstration of all the types of cell references. In this example, I'm going to demonstrate the use of mixed cell reference. So the objective here is to produce the multiplication table as shown here. On the left, we have set of numbers starting from 10 to 50. On the right side, on the top, we have numbers starting from 1 to 5. The result is multiplication of row values into column values. For example, this is a result of 10 into 1. This is a result of 10 into 2, and so on. So let's use mixed cell reference and create this table. So now select cell B4 and type equal to. Next, select the cell A4, press star, and then select the cell B3 and then press enter. After that, take the cell and drag it across the columns. Now you can see the results produced by the multiplication is incorrect. 60 is not a product of 10 into 3. 240 is not a product of 10 into 4. So this is incorrect. The results that we see is due to the use of relative reference. Here we do not want to use relative reference. Instead, we need to convert the relative reference into mixed cell reference. So select these values, remove them. Now come here. Now as you can see here, we are multiplying A4 into B3. As I drag the cell across the column, each of these column values 2, 3, 4, and 5 should also multiply with the same value A4. That means I need to fix the value A4 so that when I drag the value across the columns, it should remain intact. So let us convert A4 into a mixed cell reference. To do that, go to the edge of the A4 and press the function key F4. Press key once again and once again. So now we have converted the cell reference to mixed cell reference. Now as you drag the cell across the columns, each one of the values in the column will multiply with A4. Let us try it out. Hold the cell on the edge and drag the cell across the columns. Now you can see this value is anyway being multiplied with A4, that is B3 into A4. Now the cell C4 is multiplied with C3 into A4. This is D3 into A4, E3 into A4, and so on. Now we have fixed the cell column. The A4 is the column which is being multiplied by each of these column values. Now let us apply the same formula to the remaining rows. Drag the cell to the remaining rows. However, we have a similar problem here as well. So what we need to do is we need to convert the second cell reference, which is B3, also into mixed cell reference, so that when I drag the cell across different rows, each of the values in these rows should multiply with B3 alone. That means I need to convert this B3 into a mixed cell reference and fix the row value. So go to the edge of the cell B3, press F4, press F4 once again. This is the mixed cell reference for B3. Now when I drag the cell to the remaining rows, each of the values in these rows gets multiplied with B3. Now let's try it out. Let me drag the cells across. And as you can see, this is producing the result as expected. Now observe that this cell is a multiplication of A5 into B3. This is the multiplication of A6 into B3, A7 into B3, and A8 into B3. So we have fixed the cell B3 across different rows. Now select the entire range and then drag it across the rest of the columns. Now this operation has produced the result that we expect using the mixed cell reference. Let's now move to the third example. In the third example, I have a table here containing the salespersons, the products that they have sold, the number of units that they have sold, and also the unit price per product. So the objective here is to compute commission per person. So let's compute the commission per person. So before we compute the commission, we need to be computing sales amount. So let's compute the sales amount for the first product. Type equal to here in the cell F4, select the unit sold, enter star, and then select the unit price. Press enter. As you can see, we have the sales amount computed for Alice. Now apply the same computation for the remaining products as well. As you can see, for each of the other products, the sales amount has been correctly computed using relative reference. So this sales amount is D5 into A5, this is D6 into A6, and so on. The next step is to compute the commission per person. So go to cell G4 and then type is equal to. Now the commission is nothing but a product of sales amount and the average commission rate. So the average commission rate is here in cell B10. Now press enter. So the commission for Alice is now computed. If you apply the same computation for the other persons, you do not see any results here. That's because each of these computations are not actually referring to the average commission rate, which is 5% in B10, whereas they are referring to a different cell, which is B11. This computation is referring to B12 and so on. And that's because B12 is being referred to as a relative reference, whereas we want to use an absolute reference to cell B10. So let us correct the computation here. So let us convert B10 into an absolute reference. To do that, come to the edge of the cell and press F4. Now the cell reference has been converted to an absolute reference, and then now drag it across the other rows as well. Now you can see the commission for the remaining persons have been properly computed.